Welcome back. Before we go any further in diagnosing what's wrong and how organizations investigate failure, let's understand more about where the five whys actually came from. Understanding the origin story more deeply than the brief overview we had in the last lesson can help us to better understand why it wasn't designed to do what we're now asking it to do, the five whys tool. So we're familiar, the story begins in Japan in the early 20th century with Sakichi Toyota, the founder of Toyota Automatic Loom Works, which would eventually become the Toyota Motor Corporation. Sakichi Toyota was an inventor and an industrialist, and he instilled in his company a culture of relentless curiosity about how things work and why things break. He encouraged workers to ask why repeatedly when they encountered a problem with a loom or a manufacturing process. The idea was simple: don't just fix the symptom. Trace the chain of cause and effect until you find the thing that, if fixed, prevents the problem from coming back. Now, the person who formalized this into the method we recognize today was Taiichi Ohno, the architect of the Toyota production system. In the 1988 English translation of his book, Toyota Production System Beyond Large-Scale Production, which was actually originally published in Japanese 10 years before in 1978, Ohno described the five whys as the basis of Toyota's scientific approach, writing that by asking why 5 times whenever a problem is encountered, the nature of the problem as well as its solution becomes clear. He advised his teams to observe the production floor without preconceptions and ask why repeatedly about every matter. So he was on the production floor, dealing with machines, lathes, assembly lines, and physical components with observable mechanical behavior. Why did the machine stop? A fuse blew due to overload because a bearing wasn't lubricated, because the lubrication pump wasn't cycling enough oil, because the pump shaft was worn. This is a clean, linear chain of mechanical causation. Each link can be verified, each failure mode can be observed, and when you fix the worn pump shaft, the problem genuinely goes away. This matters because the five whys was born in an environment dominated by physical systems with relatively deterministic cause and effect relationships. Machines do not become defensive when questioned. Bearings don't fear blame. A worn pump shaft doesn't withhold information to protect itself. In that original context, the method worked and it still works very well. When troubleshooting mechanical or narrowly scoped technical failures with linear causal chains, the five whys can be an adequate tool. So I'm not arguing that the five whys has no value whatsoever. That's not what this course is about. What this course is doing is arguing that the five whys has been applied far beyond the boundaries of where it reliably works. What is less commonly understood about how the method began to drift from its original purpose, the early Toyota documentation indicates that repeated why questioning was frequently used to understand why new product features, design changes, or manufacturing techniques were needed. It was not originally developed as a formal incident investigation or safety analysis method in the way it is commonly used today. Its migration into failure investigation came later without much critical examination of whether the method was actually suited to that role. So if we want to think about how this manufacturing floor technique ended up spreading through the years across every industry, consider that the first major wave came through the global adoption of lean manufacturing. As Toyota's success became widely studied in the 1970s and 80s, organizations were rushing to replicate Toyota's methods. The five whys was adopted alongside Kaizen, just-in-time production, and other Toyota production system practices. From lean manufacturing, it was absorbed into Six Sigma programs and then spread outward into construction, healthcare, aerospace, and government. The second and most expansive wave came through the technology sector. In 2011, Eric Ries published The Lean Startup, which is one of the most influential books of the last 2 decades. Ries promoted the five whys as a core learning mechanism for startups and software teams. He wrote that at the root of every seemingly technical problem is a human problem, and he advocated making what he called a proportional investment at each level of the analyses. Ries' intentions were constructive, and his adaptation was thoughtful in a number of respects, but the reframing was consequential. A method designed to reason about mechanical systems was explicitly repositioned as a way to locate human causes. As a result, engineering teams, product organizations, and IT operations groups began using the five whys not to understand why systems failed, but to understand why people made mistakes. From there, it became embedded in incident response, DevOps postmortems, agile retrospectives, healthcare quality reviews, and project management across industries. It is worth noting that Rees himself recognized the danger in this shift. In the same book, he warned against what he called the five blames, the tendency for managers and employees to use the method not to solve problems, but to vent frustrations and call out colleagues for systemic failures. He wrote that the goal of the five whys is to help us see the objective truth that chronic problems are caused by bad process, not bad people, and remedy them accordingly. The fact that even the person most responsible for popularizing the five whys in the technology sector felt compelled to include that warning tells us something about how easily the method drifts from investigation into blame. And the method spread quickly because it was simple. You didn't need formal training or tooling or any specialized expertise. Anybody can ask why. Just keep asking why until it seems good enough. So the accessibility is appealing, particularly in organizations that don't have dedicated safety, reliability, or quality professionals. But even within Toyota, leaders recognized that the method had limitations. Hiroyuki Minura, former managing director of global purchasing for Toyota, publicly acknowledged that the five whys by itself is often too basic to analyze root causes at the depth necessary to ensure systemic issues are fully addressed. So even the organization that created the method from the get-go understood it cannot stand alone as a rigorous investigative approach. And those limitations have been documented formally. In 2017, patient safety researcher Alan J. Card published a paper in BMJ Quality and Safety titled The Problem with Five Whys. Card identified several structural weaknesses. The method tends to stop at superficial explanations. It cannot extend beyond the investigator's existing knowledge, produces non-repeatable results, and encourages the identification of a single root cause in systems where failures are actually the product of multiple interacting factors. Now, this has serious implications. Two teams can apply the five whys to the same incident and arrive at entirely different conclusions, and both are going to feel confident that they found the root cause. I don't mean to be condescending about it. It's just one of those topics that it's just amazing how much we're trained in it. I was trained in it, but it takes years later to start to really see sometimes how flawed it is, and then to discover as you research it that it's really misused and inadequate for a lot of the things it's used for. It's not a robust investigation method. It's a structured way to reinforce existing assumptions. You know, that reinforcing existing assumptions. So you can use the five whys RCA to get to the outcome you want to get to really easily, not to learn. If you can accidentally or intentionally structure it that way, and it has been used this way countless times in industry. So the trajectory is really clear. A technique developed for product improvement and mechanical problem solving on a factory floor was adopted into lean manufacturing, then Six Sigma, then startup culture, then IT operations and healthcare, and on we go. At each step, the method moved further from its original context. And at each step, the critical question whether the tool still works when applied to complex human systems operating under uncertainty, that question was very rarely asked. So let's jump into lesson 3. We're going to go ahead and walk through a realistic investigation scenario step by step and watch how the five whys transforms from a problem-solving exercise into a mechanism for blame.